going to be looking at today is reflections. Reflections across a line. Now, there's one main property with reflections, and that is if a reflection is a transformation that uses a line to mirror a figure reflected, it's going to be called the line of reflection. Now, with the line of reflection, if a point P is not on the line, of reflection, the line itself is a perpendicular bisector. If the point is not on the line of reflection, then it's a perpendicular bisector, which is nice to know because it means the distance from that point to the line of reflection is going to be the same as the distance from that line to the reflected point. Does that make sense? So the distance from the point to the line of reflection is going to be the same as the line of reflection to the point reflected. It'll be the same distance. So the distance from P to the line of reflection was 6. The other distance would be 6 as well. Because a perpendicular bisector cuts a line in half into 2 congruent segments. Now, if P is on the line, well, its reflection will be that same point. Because any point that is reflected on the line of reflection won't move. It'll be right there. And we can use this, the fact that the distance from the point to the line of reflection is going to be the same as the line of reflection to the point being reflected, or the shape. And when we deal with shapes, we're mainly going to focus on the vertices and moving those and then reconnecting them. So if we look at our first problem, we have this one here. Graph ABC with vertices 1, 3, 5, 2, and 2, 1, and its image after the reflection described. So this here is our starting image. I went on and drew it for you. So we have ABC, A, B, C. Now our line of reflection is x equals 3. In the reflected line, x equals 3. So we want to draw that line. Well, x equals 3 is going to be a line straight up and down, where x is 3. So we graph that line, x equals 3. Any questions on this here? Any questions on any of this here so far? Now, as we said just a minute ago, with this reflection, the distance a point is from the line of reflection is going to be the same as the distance from that line to the reflected point. So point A here is 1, 2 away from the line, yes? So its reflected spot is going to be 1, 2 away from the line. It's going to be a distance of 2 because it's a perpendicular bisector. Now point C down here is a unit of 1 away from the line. So I'll go a unit 1 away from the line to get C. Because the distance from that point to the line will be the same as it's reflected. B, our last point is 1, 2 away from the line. So I'm going to go 1, 2 and find B. So this here is our shape reflected. Back over here. We're going to look at another one. Let's look at this one here. So we have the same shape. If you notice that this is the same figure, A, B, C, D, same points. But the line of reflection is not x equals 3 anymore. For this one here, it's at y equals 1. So in the figure line equals y equals 1, we're talking about the horizontal line, where y is 1. Now we could use the reflection tool to kind of see what it would look like, or we can count. Let's count for this here. So if I start at this point here, well, we're going down 1, 2. So I'm going to have to go down 1, 2 to get my new A prime. B is 1 away from it, so I go down 1. What about point C? It's on the line, yes? So its new point will be the same. If a point's on the line of reflection, it stays there. And hopefully you're able to use the tools to be able to just see it, yes? Unfortunately, you won't be able to use these on the assignment, but these are kind of nifty. Any questions on this here? We're good with this here? Yes? So let's look at this next one here. So ABC, but this time, they tell us the line of reflection is at -3, where x is equal to -3. So this here will be a little bit harder to see because you'll really have to come at an angle to see it. But if we count from point A, well, we went over 1, 2, 3, 4. I'm going to have to go over 1, 2, 3, 4. I'm probably going to run out of space for this. Here, we're over 1, 2, 3, 4, 5. I'm going to go over 1, 2, 3, 4, 5. And then our other point, which is going to be way off the graph, 1, 2, 3, 4, 5, 6, 7, 8. We'd have to go over 1, 2, 3, 4, 5, 6, 7, 8. That'd be somewhere about here. There's just not enough room on this board to put the last point. But that's all we have to do for this here. Any questions on these reflections? Do we like reflections? Because we draw our line, count over to it, and then count that same amount over to find our point. And that's it. Questions on this here? Let's do one last one, and then we'll move on to the next type. So the last one we're going to look at is y equals 2, reflecting this across y equals 2. Well, y equals 2 is going to be this line here. Now, I notice that point B is on the line. So will point B move? Nope. If it's on the line of reflection, it doesn't move. Now, point A is 1 unit above, so A prime will be 1 unit below. B, or not B, C, is 1 unit below, so it'll be 1 unit above. So this here is our A prime, C prime, and B prime. This here will be our new figure. Any questions on this here? Any questions on any of this here? Are we good with this here? Yes? Okay. Now we have some coordinate rules if we're given points. We don't have to do the counting, or what I'll call the counting method. If AB is reflected across the x-axis, the reflected point will be A comma negative B. So what are we doing? If it's reflected across the x, the y value goes from positive to, or what? Negative to positive. We're just changing the sign. Because if y value is negative, it's now positive. If it was positive, it's now negative. If AB is reflected in the y-axis, then its image is negative A comma B. So we're switching the sign of x. So if reflecting across the y, it's changing the sign of x. If reflecting across the x, it's changing the sign of y. Which isn't too bad. That's kind of semi-easy to keep straight. because we're really, so reflection across the x. Our x-axis is the horizontal line, so it's going above to below. If we're talking about the y-axis, up and down, it's going from the right to the left or left to the right. Now, y equals x. What the graph that we're looking at is this line here. We're reflecting it across this line. When we talk about the reflection across y equals x, it's this line here. And when we reflect it across this line, the x and y values switch. A comma B is now B comma A. The A and B switch places. If we reflect it across the line, y equals x, the A and B flip. If we reflect it across the line, y equals negative x. Well, y equals negative x is going to be this line going down. So they do flip, but we change both signs. Negative b comma negative a. And that's it. Those are pretty much our main rules for this here. So let's look at a problem with this. Okay. We want to reflect the graph FG, negative 1, 2 for F, 1, 2 for G, across the line y equals x. Now for this here, what we're doing is we're reflecting it across this line. Now for reflection across the x, reflection across the y is not bad because x and y are both a straight line, yes? Because across the x-axis, it is just this line here. I can count. Across the y would be a straight line. I can count to it, yes? What is the distance from this point here to this point here? Do we know? It looks like it could be half, but it doesn't look like it's going to be a whole number. Most likely we're going to get some decimals. And it'd be hard to kind of estimate what that is. But what we do know, so negative 1, 2, this is F and this is G. Now I know if I reflect it across the line y equals x, I take the xy value and I switch the x and y. So for point G, this 1, 2, when it's reflected, it's going to become what? 2, 1. So that one there is not too hard to see. It's okay, well, it's here. It goes straight across that line. We can see that distance, yes? F's probably going to be somewhere down here. Well, if we do take point F, negative 1, 2, and again, we switch it, it's going to become 2, negative 1. 2, and we get this here. Now use that reflection tool, put that right on the line y equals x, and you'll see that it will mirror that. It'll mirror it right over it. That's all we have to do for this here. Questions on this here? Any questions on these reflections? We good with these here? Yes? All right, so we want to reflect this. And again, we're reflecting it across this line here. Now we can try to see if we can count and guesstimate, but I'm just going to flip them. Because when we reflect across the line y equals x, I take the point and flip it. I'm just flipping the x and y. The y becomes the x value, and the x value becomes the y value. We just flip it. So 3, -1 is going to become -1, 3. And 3, 2 is going to become 2, 3. So now I'm at -1, 3. And I'm also at 2, 3. And that's our new line. Questions on this here? Get ready for the next one. Yes? Okay, well this one here is across the line y equals -x. This line here. Well, I can guesstimate if I wanted to, but let's just use our trick. Now, when we reflect across the line y equals x, we just flipped the numbers, yes? We just flipped it. The x became y became x. But now we're reflecting across y equals -x. So what do we do this time? Because we'll still flip it, but we also do what? Change the sign. We have to change the sign of both. So -1, 2, we flip it and change both signs. Since the 2 was positive, it's now negative. Since the 1 was already negative, it's now going to be what? Positive. So one of our points is going to be at -2, 1. Now, since at our other point we have 1, 2, both values are positive. So when I reflect it this time, they're both going to be negative. So we would have 2, -1. And that's it. That's it. That's all we have to do for this here. And if I wanted to label them, we can. We can call this F and G, and this here would be F prime and G prime. Any questions on this here? Do we need to see another example of one of these? Because I feel like y'all are getting the hang of these. Yes? Well, for this one here, I'll go on and show it to you. Because we can really flip both numbers and change the sign. So the 3 is going to go in the y spot, and it would be negative since it was positive. The -1 is going to move to the x spot, and since it was negative, it's now positive. 1, -3. Our other point was at 3, 2. Well, the 3 is moving to the second spot and would be negative. The 2 is moving to the front spot, and it would be negative as well. -2. And we get this new line here. You feeling pretty comfortable with these here? Yes? No? Okay. This time they gave us a shape, didn't they? Well, if I'm reflecting this across the x-axis, well, according to our rule, if I reflect across the x-axis, the x value stays the same. We change the value of the y, yes? So we could do that. So they tell us one point is 1, 3. So I'm keeping the x value the same and changing the sign of the y. So it would go from positive to negative. Well, 4, 4 would go to 4, comma, negative 4. And last one would be 3, 1 is going to go to 3, negative 1. Now the x-axis is this line here, yes? So I can go on and plot these, but I'm going to count something real quick. So from this point here, so I'm at 1, 3, this would be J. Well, I'm how far? 1, 2, 3 above the line, yes? So I can go 1, 2, 3 below the line. Well, where's J prime at? 1, negative 3, yes? Isn't that what we got for J? Well, yeah. Our next one, K, is 1, 2, 3, 4. 1, 2, 3, 4. So K prime is at 4, negative 4. Is that what we found it to be? And last one is a 1 above, so it's going to be 1 below. So at the x-axis, I can actually count because it's a straight line. I can count straight down to it, or we can use our rule. Either one will work. Questions on this here? Any questions on any of this here so far? Okay, well, let's look at another one. So we want to graph this across the y-axis. Well, I could use the y-axis and count over to it, couldn't I? So I can start at this point here and count 1 over, because this here is the y-axis. So it's a distance of 1 away from it. So its reflection will be a distance of 1. This point up here is 1, 2, 3, 4. So I'm going to go over 1, 2, 3, 4. This point here is 1, 2, 3, 1, 2, 3. Or we could have taken this point and switched the value of the sign in front of the x. Because our first point was at 1, 3. 1, 3 up here. Well, if I switched it, I would have been at negative 1, 3. And doing that rule will give us the same points. So for y equals or x equals, it's easy to use the rule, or we can just count. Questions on this here? All right, this time we're reflecting across the line y equals x. So we can count, but I'd rather use the rule for this one here and y equals negative x. Now for the line y equals x, we're doing what? We're switching the values of a and b. We're not doing anything else. We're just flipping them, yes? So the x value goes to the y value goes to the x. So for the first one here, 1, 3, if I reflect it across the line, y equals x, I flip those values, and I get what? 3, 1. Okay, let's flip 4, 4. What would 4, 4 reflected be? It'd be what? 4 and 4? Isn't that what we started with? Well, that's because why? Because what did we say? If it is on the, and that's on the line. And last one would be 1 and 3. So we're going to have 3, 1, 1, 3. What happened to this figure? Well, it did move. But what happened to it? It flipped. It flipped on itself, yes? So it'd be the same as looking in a mirror. Yes? Because when you look at a mirror, is it the exact same image as what you're looking at? No, it's a flip. It is a mirrored image. So here, it reflected on itself. Each point's reflected onto itself. The line y equals negative x. So again, if we use these points, now we're going to flip them again, because y equals negative x. You flip the x and y, you switch their spots. But with y equals negative x, we change both signs. We change both signs. So the first one would be 3, 1, but they would both be negative. Well, 4 and 4, when we flip it, it would just be 4 and 4. But again, they're both going to be, and the same thing is true for the last one. Any questions on any of this here? Now all we need to do is graph it. So we'd be at negative 3, negative 1, negative 1, negative 3, and at negative 4, negative 4. And we get this triangle here. Any questions on any of this here? Do we feel good with this here? Yes? Okay. This is as hard as we can make reflections. There's nothing wrong with doing both. We don't have to do just reflections. We can do translations and reflections. We can do both. So here I have a translation and I have a reflection. Now what is the translation telling me? X minus 12 and y. So are we moving it up and down at all? No, y staying the same, but what are we doing to the x? 12 to the left, because we're subtracting 12 from each point. So I'm going to take each point and move it 12 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next point. So we start here. And go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And our last point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we just moved all of these here 12 units to the left. Yes? We're good with that there. Because that's what we did yesterday, moving it up, down, left, right. So we did the first move. Check. Now what does it want? A reflection in the x-axis, yes? So that means we are talking about this line here. And we could count, because I can say that this point is one above the line of reflection, so the new one's going to be one below. This top point here is 1, 2, 3 above, so it's going to be 1, 2, 3 below. This point here is 1, 2 above, so it's going to be 1, 2 below. So we get this figure here. Questions on this here? Any questions on this here?
Would there be 2 lines after that?
Yes. So we started out at A, B, C. We'd have A prime, B prime, well, not B double prime, B prime and C prime, and this here would be A double prime, B double prime, and C double prime. Questions on this here? And on the homework, it's going to want you to graph all three. It's going to want all three. Questions on this here? Yes, sir.
You always do the translation before the reflection?
Let's do it the other way. I would do it on the big ideas math. I would do translation and then reflection. Do it in the order they gave us. Yeah, you can see it there. Let's do it in the other order. Let's reflect it across the x-axis first. Well, that would be 1, because we have a distance of 1, 2. So I'm going to go down 1, 2. Here we're 1, 1, 2, 3. 1, 2, 3. Here we are 1. So I go down 1. So I have this figure here, yes? So for simplicity's sake, I'm just going to move the whole figure. That'd be 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Did that end up in the exact same place? Yeah. So translation and rotation, or not translation and rotation, translation and reflection for this year end up getting us in the same spot. So it works out for this year. But for the homework, I would do it in the order they gave you because I have a feeling it's wanting them in a specific spot. And there might be some cases that we come across where the order in which we do them will matter, but for the most part, it shouldn't. It's not going to matter too much. Questions on this here? I think, yep, this here is the last one we're going to do. Let's do them in the order that they're done. So the first one is x comma y minus 6. So that means we're taking every point on this triangle and doing what to it? Moving it down 6. So this point here is going to go down 1, 2, 3, 4, 5, 6. This point here is going to go down 1, 2, 3, 4, 5, 6. Now we can do that, but I want to actually, now that I think about it, I'm going to do this differently. I want to do this differently. Three, 2 is our first point, yes? So you can watch this, you can do the counting method. I want to show you this mathematically. So it's saying, for this translation here, we take the x, y, and when we translate it, it's going to be x comma y minus 6, yes? So what I have here is 3 comma 2 minus 6. Well, that would be 3 comma negative 4, yes? Then what happens? It's a reflection across the y-axis. Well, our rule for the reflection across the y-axis is that we take the value of a and make it negative. So our next translation would take 3 negative 4 to negative 3 negative 4. Negative 3 negative 4. And that's it. Okay, I'm going to have to erase this because I don't have space to do each one. Now we can do it with 6, 3, which would be 6 comma 3 minus 6, which is going to be 6 comma negative 3 after we translate it. And again, the reflection across the y is we're just changing the sign for the x value. So this would be negative 6 comma negative 3. Negative 6, negative 3. And lastly, 7, 1, which would be the same as 7 comma 1 minus 6 because of our translation, which would be our 7 negative 5. Which would be our negative 7, negative 5, which would be down here. Negative 7, negative 5. Right here. 6, 3, negative 6, negative 3. Yep, that's better. Now, you could have gotten the same things by doing our counting method, counting down, counting over, but we could plug the numbers into both of those, so that formulas can get the same spot. Questions on this here? Any questions on any of this here? Does that make sense? Yes? Not too bad? Now, are we restricted to just having a translation to the right or left or just up and down? Well, no, I can move these shapes to the right and up or left and down. I can move them in both directions and reflect it across the y-axis, yes? Can I reflect something across the x and y-axis? Let's see that. So if I take a comma b and I reflect it across the x-axis, well, that would be a comma negative b, yes? What happens if I reflect it again across the, so that was x, y would, reflecting this x-axis. What would it become if I reflected across the y-axis? So I can reflect it across both. Well, that's the same as y equals negative x, yes? Okay, say I start out with the point negative a, negative b. Reflected across the x would be negative a comma b. Reflected across the y would be a comma b. So I can reflect it across both. But it's almost the same as these here. But that's it. That's all we're going to cover.